Okay. Till 5.2, I think we have done the differentiation. Then 5.3, before we start the exercise, we have the two words
Morning,
to
sir.
understand. Good morning. We have two words to understand. One is implicit and another one is explicit functions. If you look at into the examples which are mentioned here, that is x minus y minus pi equals to 0. This is one example. And another example is x plus sine xy minus y equals to 0. So if I note down both the examples here, what you have, x minus y plus pi x minus y plus pi is equals to 0. So this is one equation they are given. Another equation is something x plus sine of xy maybe minus y is equals to 0. Now here, if you want, I can write this equation as maybe y equals to x plus pi. Can we represent? Just I am transferring y to the right hand side, minus y will become plus y. So y equals to x plus pi. That means the function y is expressed in terms of x completely. But if you look at into the second example, can I express this y equals to in terms of x? Is it possible to express? Maximum here I can write x plus sine y, sine xy is equals to y. That's it. Further I cannot simplify anything because this is sine of xy. So the second function you cannot completely represent y equals to in terms of x and constant terms. Even here written y, but still there is a y term here. Okay. So by knowing the value of x, I cannot find value of y in this equation. But here if I know the value of x, then I can give you the value of y. But that is not the case here. If you know the value of x, you cannot find the value of y. So these are the two different types of functions. One is I can express one term in terms of other terms, and another one is which I cannot express. So y equals to x minus y, in the second case, it does not seem to be there is easy way to solve for y. So when the relationship between x and y is expressed in a way that it is easy to solve for y, or you can write y equals to f of x, we say that y is an implicit function. So that means in the first case, the given function is implicit function, where I can represent y in terms of x or x in terms of y. Where the second case, where which you cannot represent, that functions we call as explicit function. Okay, so these are the two words you have to understand. Now, how do you differentiate the implicit or explicit functions? For example, if I take first function, this one, if I do differentiation of this function with respect to x, then what you get is this is going to be dy upon dx, which is equals to, this is the function I am differentiating with respect to x. So y with respect to x is dy by dx, and derivative of x is 1 plus derivative of pi. Pi is a constant number, maybe 180 degrees, or it's 22 by 7. So pi is a constant number, and the derivative of a constant number is going to be 0. So finally it is dy by dx equals to 1. Now if I want to differentiate this type of function, which are implicit functions, so how do I differentiate? Just take this an example. How do we differentiate? So here you have to write that condition, differentiate this function with respect to x. Let's see what will come. Or if you want, let me remove this one. if I differentiate this one with respect to x, differentiate of x with respect to x is going to be 1 plus, now differentiation of sine theta. Derivative of sine is cos theta, so it is going to be cos xy into derivative of xy. Derivative of xy will come according to the chain rule minus, now derivative of y with respect to x. So derivative of y with respect to x will come as y dash. Instead of dy by dx, I'll use y dash. Okay, this is what I use for the dy by dx for easy to write. So next step is going to be, this is not over h because still I have derivative of xy is left out. So this has to be derivative. Now what you get here, it is 1 plus this cos xy will remain as it is. Okay, if you want, I'll put the closure brackets here. So let me insert the bracket. Now in the closure bracket, I'll write derivative of xy. This is the product of two functions. So I have to find the derivative of xy with respect to uv formula. What is uv formula? U into derivative of v, derivative of y. So derivative of y will come again as y dash only. U derivative of v plus v into derivative of u. Derivative of u is derivative of x, which is going to be 1 only. Derivative of x with respect to x is going to be 1 only. Okay. Now if I open up the bracket here, because I want to bring all dy by dx terms at one place and all other terms to other place. Okay. So let me see, if I open up the bracket, first one will be there plus this cos xy will multiply with first term as well as with second term. So if I multiply, what do you get? Here I have xy dash, it will be xy dash into cos xy, xy dash into cos xy, then plus y into cos xy, y into cos xy is equals to this y dash is going to remain as it is. Now what I have to do is bring all the y dash terms to one side and other terms will be on the same side. So let me insert again equation. So this will give me 1 plus this y cos xy I'll keep as on the left side of the equality only, which is equals to, now what happens is this y dash will be on the right hand side only, minus this entire negative term or positive term is going to be negative term if I transpose after equality. Okay, so next this RHS will remain same, sorry, LHS will remain same. Now what I do here on the right hand side is I can take y dash common. If you take y dash common, what you left out? First case 1 will be left out minus x cos xy will be left out. If you want derivative final answer, so let me write the final answer. Insert equation fraction. Your numerator is going to be LHS term as it is, and the denominator is going to be this entire term, which is equals to y dash. This y dash term will remain as it is. So this is the final answer or derivative of the given function. Y dash equals to 1 plus y cos xy upon 1 minus x cos xy equals equals to y dash. This is the derivative of the explicit function. Okay, is this one clear? How to differentiate this function? Sorry, implicit function derivative. The second one is implicit. The first one is explicit. Is the derivation is clear for everyone, or anyone has doubts? Yes. Thank you. Your messages are taking time to teach.
Yes, sir.
Yeah, clear. Good. Now, before we go to the actual exercise, the next 5.3 exercise is based on derivative of inverse trigonometric function. So for those, we have certain formulas for inverse trigonometric function. For all the 6 trigonometric inverse function, derivative of sine inverse x is 1 upon 1 minus x square. Derivative of cos inverse x is minus 1 upon 1 minus x square. Derivative of tan inverse x is 1 upon 1 plus x square. Derivative of cot inverse is minus 1 upon 1 plus x square. And similarly for sec and cosec, we have the formula. Here actually derivative of sine inverse x and cos inverse x formula is same, only the sine will be there in the numerator. And derivative of tan and cot formulas are same, only negative sign in the numerator. And similarly for sec and cosec formula is same, one sign will be different. So what we do is we'll try to derive one of the formula. Okay, so for example, if I want to find the I have to prove derivative of sine inverse x is 1 upon 1 minus x square. So what I do here is sine inverse x equals to y. So I'm considering here let sine inverse of x equals to y. So according to the inverse property, then I can write x equals to sine y. Okay. So if I differentiate with respect to x on both sides. So this statement you have to write every year. Okay. So if I differentiate with respect to on both the sides, derivative of x is 1 and derivative of sine y is going to be cos y into dy by dx. Dy by dx is going to be y dash. Where is this dash? Yeah. According to the chain rule, first derivative of sine y is going to be cos y. So I got it cos y and into derivative of y, that is dy by dx. So which is going to be 1 equals to, I think font size is decreased. Yeah, 1 equals to, see here I know sine y value is in terms of x. So when I differentiate sine inverse x, my answer is also going to be obviously in terms of x only. So, but here I have cos y. So I want to convert this cos y into in terms of sine y, because sine y value is going to be x. So according to the identity, sine square theta plus cos square theta equals to 1. Then I'll get cos square theta equals to 1 minus sine square theta. Right? Then cos theta equals to under root 1 minus sine square theta. If you want, you can insert the formula here according to the which identity we are using. No, let me put here cos y is equals to, let me insert the equation. We want under root term, under root 1 minus sine square y. I think everybody is familiar with this formula. Okay, cos y equals to, this is the formula which we have according to that sine square theta plus cos square theta equals to 1. So cos y I'll replace with as this one, multiply by this y dash. Okay, so this will come multiply by y dash. Then what happens now if I replace sine y value as x, because that's what we assume, right? X equals to sine y. So in place of sine y, if I put x, this is going to be x square. So finally I have 1 equals to under root, let me insert the equation, under root 1 minus x square will come, under root 1 minus x square multiply by y dash. So this is going to be y dash. So if I want y dash, then what happens? That under root 1 minus x square will come to the denominator to the left hand side. So it will become 1 upon yeah, 1 upon under root y square. I mean 1 minus x square is equals to this y dash. So y dash means derivative of y. Derivative of y means derivative of sine inverse x. Okay, so derivative of sine inverse x, I got it as 1 upon 1 minus x square. Now, why derivative of cos is coming negative here? Because if the same technique, whatever I applied the technique here, if I apply the same technique, here what you have done, you have taken x as sine y and derivative of sine y you have written as cos y. If I do the derivative of cos, I know derivative of cos is going to be minus sine. So here you are going to get minus sine. So that minus is going to be here, here, and finally here. That's why derivative of cos you are going to get minus 1 upon under root 1 minus x square. Okay, so this formula derivation is clear. Derivative of sine inverse x. So similarly, you can apply derivative of cos inverse x, derivative of tan inverse x, derivative of cot inverse x, everything you can apply. I think in the textbook they are given derivative of tan inverse x also. Y equals to tan inverse x, then tan x equals to y, sorry, x equals to tan y. Then if I differentiate with respect to x and both, the derivative of x is going to be 1. Derivative of tan x is sec square x dy by dx. Now sec square x, according to the formula, you can write as 1 plus tan square y. So sec square x you can replace as 1 plus tan square y. Okay, so that's how you'll get it. You try in the notebook. Now in every question, find dy by dx in the following questions. So first question, second question, third question. Let me solve the third question. Ax plus by square equals to cos y. So let me go to the third exercise. Third question of the exercise. So let me insert the equation only. Ax plus by square. So by square, what is another term is given, equals to cos y, is equals to cos y. Now I have to differentiate with respect to x on both the sides. There is that word. So everywhere this statement I can use it. Where is this? Yeah. And differentiate with respect to x on both the sides. So what do you get? A differentiation of ax. Here a is a constant term and x is a variable term. We don't need to apply the UV formula actually. You can apply no problem, but simplest way, derivative of 2x is 2 because 2 is a constant. So here also a is a constant, derivative of ax is a only. Now what about the derivative of by square? So here derivative of ax, I'll get it as a. by square. So b I no need to differentiate. Now differentiation of y square is what is the derivative of x power n into x power n minus 1. So differentiation of y square is going to be 2y into y dash, because I am differentiating y with respect to x, so it is going to be y dash, which is equals to differentiation of cos y is minus sin y into, again y dash will come because the differentiation of y with respect to x is going to be y dash. Okay, now what you can do is bring y dash terms one side and all other terms to other side. So I keep a here only, equals to this minus sin y dash, and the RHS will remain RHS only. Now this term plus 2by y dash is transferring to the right side of the equality. So this is going to be minus, so instead of writing 2 here, I'll put the friend 2by y dash. So again, next step, you already aware what will be the next step. Take y dash common from the terms and see what you're going to get. If I take this, a will be remain as this. If I take y dash common from both the terms, so we are going to get what is mine. I think minus also I can put common, minus y dash common because the sign term. So here you left out with sin y, as I have taken minus common, so plus, then you will get 2by only. So final step answer, next step will be, if I want y dash, it is going to be minus a upon sin y plus 2by. So that is what the answer is going to be for third question. So let me write the answer also here. Numerator a will minus a I'll keep because this minus and I'll transfer to that side, and the denominator is going to be sin y plus 2by, so which is equals to y dash, that is derivative of the first function, I mean given function. Okay, that's how you do that dy by dx for the third question. Is it clear for everyone? Has anyone has doubts? Expect the answer yes or no from everyone. Okay. So then you have, I think, let me take the, you want fourth, fifth, or sixth question? Which one you want? Fourth, fifth, or sixth? I think everybody will go for sixth question. So let me take the print screen here. So I'll go for the sixth question, even though it is easy, but look. So let me crop the image. Yeah. This is the actual given question of the sixth one. Sorry. Yeah. Now I have to find the dy by dx for this question. X cube plus 3x square y plus xy square plus y cube equals to 81. So you write the step differentiate with respect to x on both the sides. So derivative of x cube is going to be 3x square. Okay. It's going to be 3x square plus, plus, now what I do is x square y. So both the variables are there. So we are going to use UV formula. Okay. So UV formula is u into derivative of v. So u means x square into derivative of v. That is derivative of y. Derivative of y is going to be y dash. Okay. U derivative of v plus v into derivative of u. Derivative of u means derivative of x square, which is going to be 2x. So this second term derivation is done. Now come to the third term, x y square derivation. So this is again a combination of two functions, two variables, x and y. So I have to go for the UV formula here again. UV formula means again u into derivative of y square. Derivative of y square is 2y into derivative of y. Derivative of y is going to be y dash. Okay. U derivative of v is done plus v derivative of u. V means it will come y square. This is going to be y square into derivative of x. Derivative of x is going to be 1. Okay. Derivative of x with respect to x is going to be 1 plus derivative of y cube. Now fourth term derivative I have to find. Derivative of y cube is 3y square. Okay, it is going to be 3y square into derivative of y, which is equals to derivative of 81. Derivative of 81 is going to be 0 because 81 is a constant. So in the second term, third term, I have applied the UV formulas. U derivative of v plus v derivative of u, even here also. And here y cube derivative, I use the formula derivative of x power n is n into x power n minus 1. So derivative of y cube is 3 into y power 3 minus 1, which is 2. Because y, that's why I have to put y dash. Now what you do is keep next step. Keep all the terms which involves y square on one side and all the terms which does not involve the y dash term to the other side. For example, here x square y dash. So I keep y dash terms on the left side. And then plus this 2xy dash is also involves y dash term. So this also I'll keep here, but let me keep 2 before the variable. So this term also involves y dash, and there is one more term which involves y dash. So that also I'll keep here only with plus sign. Why I'm putting plus sign? Because there is a plus sign here. Now here equals to, now rest all other terms which does not involve y dash term, I am transferring to the right side of the equality because all the terms are positive. Now every term is going to be negative. It changes in it. So plus 3x square will go as minus 3x square. This plus 2y into 2x is going to be minus 2xy. Okay. Anything else is this plus y square is going to be minus y square here. Okay. So all the positive terms are transferred y dash terms one side and all other terms will be on the other side. Now what happens? Obviously next step, y dash you are going to take common. Let me insert the equation here. Not square. This is going to be y dash you have to take common. After taking y dash common, what other terms will be left out here? X square will be left out in the first equation plus 2xy will be left out in the second equation plus 3y square will be left out in the third term, which is equals to, I think these terms you can keep as it is, no need to simplify. I think minus 3y square, maybe if you want you can factorize, otherwise you can keep as it is. So final step is y dash, because I want dy by dx, right? So rest all the term has to transfer after equality. So before equality you should have only y dash. So numerator is going to be this RHS term will remain as it is, and here this term, because this is the product, it will transfer to the right hand side as a division. Okay, so this is the solution of the sixth question answer. So just you have to apply UV formula or U by V formula and so on. Okay, now I think fourth and fifth you can solve. Sixth also, this is sine square y. Derivative of sine square y is going to be 2 sine y into derivative of sine y is cos y into derivative of y is y dash. So cos xy derivative is going to be minus sine xy into derivative of xy. Okay. Now from question number 9, 10, 11, 12, 13, 14, 15, these all have the formulas to be substituted here first of all. Okay. So what formulas we have to substitute? Which question you want me to take? We already solved this formula. Let me go for question number 10. Even question number 9, 10, 11, you have to substitute what you call same term. So let me take question number 10. Let me crop the question. So this is the basic question is given. So what I substitute here is let x equals to tan and it's maybe tan z. I substitute x value as tan z. So how your question is going to change? So you'll get y equals to, let me put here, y equals to tan inverse. You want tan inverse here, followed by bracket, followed by fraction. Now here in the given question, I'm going to replace x as tan z. 3 tan. What I do is, let me take theta instead of z. This z looks a little bit weird. Tan theta only. So 3 tan theta minus tan cube theta. So to insert tan cube theta, this is going to be tan cube theta. Okay, 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. This is the term which is going to be after replacing x as tan theta, tan square theta. So do you think is this the formula for any term? 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. If anyone remember this formula, if you know the formula, just type your answer. I'll check it out. Any idea what is the formula for this 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Let me check. No one remember? So you can refer your book. Tan square. So this is the formula of tan 3 theta. Okay. So this is the formula of tan 3 theta. So finally, it is tan inverse of tan 3 theta is going to be 3 theta only. So finally, you have y equals to 3 theta, because tan inverse of tan theta is going to be theta only. So here you have 3 theta, that's why it is going to be 3 theta. Now next case, you can replace theta value, whatever we assume, y equals to 3 times. Now here I have to replace theta value. What actually I assumed, x equals to tan theta. That's what I assume. If I want theta value, it is going to be tan inverse x. So here I am going to replace it as tan inverse x. So y equals to 3 times of tan inverse x. Now you can simplify or differentiate this one. So differentiation of y is going to be y dash. So let me write the final answer. Yeah, just 1 or 2 steps to get your answer. Instead of dy by dx, I'll put y dash only. Y dash, this is the differentiation of y with respect to x. 3 will remain as it is. What we discussed, differentiation of tan inverse x. Just now I shown the formula. Derivative of tan inverse x is 1 upon 1 plus x square. Okay. So this is our answer. 3 into 1 upon 1 plus x square. That is the answer of this question. There is another way also to solve this question. Instead of substitution, if you don't know what to substitute, y equals to tan inverse 3x minus x cube upon 1 minus 3x square, right? So the same thing you can write here it as, if I bring tan to the left hand side, it is going to be tan y is equals to 3x minus x cube. Let me write 3x minus x cube upon 1 minus 3x square, 1 minus 3x square. Now you can differentiate on both the sides. Okay. How do you differentiate is, it will be tan y differentiation is, what is the differentiation of tan y? I think log mod sin x, derivative of sin, something is there, just find out. And here you are going to apply what your u by v formula. So this process is going to be too lengthy if I solve by this method, but still you will get the answer. Again, I repeat, the way if you solve this way, the answer which you are going to get does not look like this way. Okay, it may be some terms are different, but x will satisfy the given condition, minus 1 by root 3 to plus 1 by root 3. This condition will be satisfied even if you solve by this method. Okay. So this also you can go and solve. Even here also you represent in question number 9, you take x as tan theta, then you'll get 2 tan theta upon 1 plus tan square theta. This is the formula of sin 2 theta. So sin inverse of sin 2 theta is going to be 2 theta. So you'll get y equals to 2 theta. Then theta value will be sin inverse of x. Okay. Because, sorry, tan inverse of x. Theta is going to be tan inverse. So 2 tan inverse of x, then differentiation will come 2 into 1 upon 1 plus x square. Even question number 11 also, you can substitute x as tan theta. You have 1 minus tan square theta upon 1 plus tan square theta. So this is going to be the formula of cos 2 theta. Okay. Question number 12 I will solve now. Let me take the screenshot. Which one I said? Question number 12, right? Yeah. You can see the time. Do you have any class after 12 o'clock? Or at 12 o'clock?
So 2 o'clock.
2 o'clock, no problem. So we'll finish this exercise here. Now here again the same substitution I'll go. Let x equals to tan theta. Achha, I need to copy this theta symbol. Let x equals to tan theta. So what you're going to get here it is, can I write the step? In the exam you include the step. What I do is I'll put directly y equals to this is one sine inverse, right? Sine inverse or you want me to write one step. This you'll get 1 minus tan square theta upon 1 plus tan square theta. That is the formula which is going to be cos 2 theta. 1 minus tan square theta upon 1 plus tan square theta is going to be cos to the sine upon cos. Both will get cancelled. Okay, but here the problem arises. This is a sine inverse of cos 2 theta. If I have sine inverse of sine theta, then I can write answer as theta, but this is going to be cos 2 theta. Okay, so how do I convert cos 2 theta in terms of sine? Any idea? Cos theta is nothing but sine 90 minus theta. Okay, so this is the process. I'm going to use the same technique here now. It is going to be sine inverse of cos theta. You can write as sine 90 minus theta. So which is going to be sine. Let me put the bracket here. Sine 90 minus theta. Let me put angles only. 90 degrees minus 2 theta. Is that okay? Cos theta is sine 90 minus theta. That is the formula which we already studied. Or sine 90 minus theta equals to cos theta. Why I have to convert this cos into sine? Because front here you have sine inverse formula. So that's why you have to convert cos term into sine term. I don't convert sine inverse into cos inverse. That's not possible. So that's why I convert this cos theta into sine 90 minus theta. So next step what you are going to get, I think next step onwards we can solve easily. Y equals to, now sine inverse of sine theta, which is going to be 90 minus 2 theta. 90 minus 2 theta. So next step you are going to replace theta value, which is going to be y equals to 90 minus 2 into what we assumed x is tan theta. So theta will be tan inverse of theta. So tan inverse of x will come, sorry. This will be tan inverse of x. Now you can differentiate with respect to x on both the sides. Derivative of y is going to be y dash. So derivative of y is going to be y dash, which is equals to derivative of 90 is going to be 0 minus 2 into derivative of tan inverse x is going to be 1 upon 1 plus x square. 1 upon 1 plus x square. So this is our final answer of that question. So that 2 theta formulas, 3 theta formulas you have to remember in terms of sine, in terms of cos, in terms of tan. So rest of the things also you try it out. Question number 15, yeah. Okay. So keep solving. In the next class, I think we have trigonometry, logarithmic and exponential functions.